Hi students, this is Mr. Yao. In this lesson, we are going to continue to learn more about quadratic functions. Previously, we had learned different forms, and we had mentioned a few things about graphing, so now we're going to put our focus on graphing quadratic functions. First, before we actually get into the graphs, we are going to work on some vocabulary. If you're just watching the video to learn, I'm going to ask you to pause here and try to see if you can use the word bank that's given to you in your notes to fill in some of the blanks. For question 3 and 4, you just need to fill out the first blank and ignore the rest. The other ones, you should be able to figure them out. Now that you have some time, let's have a look. The first one, standard form of a quadratic function. That's something we have been working with in 4.9. f of x equals ax squared plus bx plus c. Of course, there's one requirement. This a can't be 0. Because if a is 0, we don't even have an x squared. Next, we had mentioned in the previous lesson, the shape of a quadratic function graph is called a parabola, not a parabola, it's called a parabola. And it typically looks like this. It's a parabola. Then C is a specific point. It's the vertex. Vertex is the point where the parabola changes direction. Vertex is the highest point or the lowest point on the parabola. In this case, it is the lowest point. And then something else we have mentioned in the previous lesson, axis of symmetry. The vertex is actually on the line of symmetry. The line that cuts the parabola exactly in half. It is always a vertical line of the form x equals something. Because if it's crossing the x-axis at a certain point, it's always x equals something. The vertex is also always on the axis of symmetry. So something else, even though we put an n here, technically we will always get x equals h. Since vertex is on the axis of symmetry, which means they share the same x value, so it's going to be x equals h. Moving on, E. When the vertex is the highest point on the graph, we call that a maximum. So highest point looks like this, so of course that's the highest point, it's a maximum. Quadratic function is a function that can be written in the form of f of x equals ax squared plus bx plus c, where a does not equal to 0. Our solutions to equations are the zeros, roots, or, well, actually shouldn't be solutions, x-intercepts. So that's a typo. And H, solutions to quadratic equations are called x-intercepts on the graph. And when the vertex is the lowest point on the graph, we call that a minimum. So like this, a minimum. And lastly, f of x equals x squared, that's a quadratic parent function. That basically means it takes the most basic form of a quadratic function with nothing else. Like you see no x, no number, and the x squared doesn't even have a number in the front. So that's the most basic form. Now we're actually going to talk about graph by plotting. Plotting just means we are going to pick some points, and then we're going to connect those points, or more precisely, we're going to pick some x values, then we're going to, based on the x values, calculate the y values, and then put those points on the graph, and we are going to connect them. So let me kind of write down the process. First, we're going to pick x values, and then we're going to calculate y values. Afterwards, we are going to put down points. And lastly, we're going to connect all the points smoothly into a curve. We're not exactly, we can't exactly just connect them into a straight line. So there you go. In this case, well, I'm going to give you a point to pick in the middle, because typically when you try to plot something, you're going to need a point in the middle and some on the left, some on the right. So you're graphing a shape that's kind of symmetric, especially in this case. So when x equals 0, 0 squared is also 0. And then we're going to go left by 1, go left by 2, then go right by 1, and go right by 2. 5 points is pretty plenty. When x is -1, we got -1 squared, which is actually a 1. When x is -2, we got -2 squared, which is a 4. And then 1 squared is just a 1, and 2 squared is a 4. So our points are -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. We are going to connect them a little bit off. We're going to connect them smoothly on both sides. And that is our parabola. Okay, the left side seems to be a little bit off. Let me regraph that. There you go. So that's a parabola. Now let's do the same thing. For this one, I'll tell you the middle point you can still pick is 0. So I'm going to ask you to pause here, calculate. So you're going to go 1 left, 2 left, 1 right, 2 right, then calculate all of these points, then put them down on the graph. Of course, later we're going to learn some other ways to be able to move from a parent function to generate the new graphs. But for now, not there yet. Okay, here are the values you should be getting. 2 times 0 squared minus 3 is a negative 3. 2 times negative 1 squared minus 3, that's a 2 minus 3, which is a negative 1. Negative 2, well, 2 times negative 2 squared, that's going to give you an 8 minus 3, which is a 5. And then we have 2 times 1 squared minus 3 is still a negative 1. And then 2 times 2 squared minus 3 is a 5. You can see they are symmetric. So 0 is at negative 3. And then negative 1 is at negative 1. 1 is also at negative 1. Then we went up to 5 for negative 2 and 2. There you go. And we are going to connect them smoothly into a parabola shape. That's example 2. Moving on, example 3. For this one, it's a little bit different. The value that we are going to pick in the middle is not going to be 0, 0 anymore. The reason is, well, we actually have this 4x. So if you think about it, if you use the vertex form that we have learned, if you try to calculate what h is, because the vertex is right in the middle, so we typically pick that as a middle point. So if you calculate h is going to be negative b, which is 4 over 2a, 2 times 2. So it's a negative 4 over 4, which is negative 1. That's why right in the middle, we're going to pick negative 1. Then 1 left, 2 left, 1 right, 2 right. Okay, we're going to plug them in to calculate. So when it's negative 1, we got 2 times negative 1 squared plus 4 times negative 1 minus 5. That is going to give us a 2 times 1, which is a 2, minus 4 is a negative 2, minus 5 is a negative 7. When it's negative 2, 2 times negative 2 squared, that's an 8, plus 4 times negative 2, that's a minus 8, minus 5 is a negative 5. 2 times negative 3 squared, plus 4 times negative 3. Negative 3 squared is a 9, times 2 is an 18, minus 12 is a 6, minus 5 is a 1. And on the other side, you should already know, they're going to give you the same value because the whole thing is symmetric. So negative 3 is at 1, negative 2 is at negative 5, and negative 1 is at negative 7, and then 0 is at negative 5, and 1 is at 1. So there you go. There's our parabola. You can see it looks a little bit narrower compared to the previous ones, but it looks very similar to the second one, just in a different location. So there you go. That's example 3. We're of course going to learn more ways to graph quadratic functions. This is just the most basic way, is graph by plotting. Moving on, maximum minimum points of a quadratic function. So the vertex of a quadratic function or parabola is also the maximum or minimum point. But how can we decide? By just looking at the question, we should actually be able to tell pretty quickly, because we can see if my graph looks like that, we have a minimum. If my graph looks like this, we have a maximum. And that is all decided by the value a. If a is greater than 0, which actually means it's opening up, it's going to be in a minimum point. If a is less than 0, which means it actually opens down, then we actually have a maximum point. So there you go. A decides the direction where our parabola opens. So let's have a look at 2 examples. Example 4, example 5. They're actually already given in vertex form, so it should be fairly quick. The vertex, again, make sure h, you're using the opposite of whatever is given in the function. So it's going to be -2, -3. And in this case, our A is going to be, well, just this 1 in the front, which is greater than 0, which means our graph actually opens up. So it's going to be a minimum point. Pause here and try the next one. Okay, so it's the same thing. Vertex is going to be the opposite of whatever is in the function. So it's positive 8 and 4. Our A is the number in the front, which is this -5, which is less than 0, which means our graph actually opens down. So I would recommend you not trying to just memorize, oh, it's maximum or the minimum point. Just remember it as which direction is actually opening, because that's going to be useful. We're going to actually use that a lot in the future for transformation. So now we know it opens down, which means it has to be a maximum point. That is everything for this 4.10a lesson. Thank you.